first. Okay, as I was explaining before, section 3.4 is what we're going to next. We're skipping 3.3. And 3.4 is called using the quadratic formula. If you want to start looking, well, there's nothing in the book I want you to see yet. There's quite a bit of foundation work we've got to put together first so that you can understand where this comes from. Now listen, if after I derive the quadratic formula for you, we talk our way through it, you see if you can understand it. If you can derive it from knowing where to start, clear to the bottom of it without any mistakes and showing all the steps on the next test, I'll give you extra 10 points. Extra 10 points. So you may want to write some things down, or go look at this video and write it down, or take a look at it before the test so you got it down really well. Anyway, I will derive that in a few minutes. There's a little bit of foundational work I've got to put together for you first that you probably aren't aware of. But I'm going to show you. So, if you consider this number right here, we call this particular number, there's millions of them, but we call this particular number a perfect square number because when you factor it, it factors into two things that are exactly alike. That's why it's a perfect square number. And rather than saying 7 times 7, we often write it like that. That's a little more clear that it's a perfect square number. 49 is a perfect square number because it takes two things that are exactly the same when you multiply them together to get it. That makes good sense, right? Well, I'm here to tell you that this thingy right here, x squared plus 6x plus 9, that's not the only one. This is just an example. There's millions of these too. This is called a perfect square trinomial. Trinomial because there's 3 terms. Perfect square trinomial because when you factor it, factors of 9 that add up to 6, you get exactly the same thing twice, just like we did with this. But we call it this. Okay? Just like 49 is a perfect square because it's 7 times 7, this is a perfect square because it's x plus 3 times x plus 3. There are certain things about perfect square trinomials that are always the same. First of all, this is a 1. Secondly, half of this term squared is always this one. Here's another perfect square trinomial. X squared plus 10x. Let me make it minus just for sake of variety. Minus 10x plus 25. By the way, if it's a perfect square trinomial, the last term will always be positive. Always. What does this factor into without the intermediate step?
X minus 5.
Correct. X minus 5. When you factor a perfect square trinomial, if you're sure that's what it is, then the factoring will always be one of these x's, and half of this with its sign. Squared. Every time. So let's try this instead. Let's see if you can tell me what has to go on the back end and then help me factor it. If I have x squared minus 6x, no, I already did that one. X squared minus 14x plus what would make that a perfect square trinomial?
49.
Who said 49? Who said 49 right up? I only got about 3 or 4 voices. It is 49. I want to know if the rest of you understand that. And if you don't, you got to speak up. Half of 14. It doesn't matter whether it's positive or negative, because half of negative 14 is negative 7, but negative 7 squared is still positive 49. So you're correct. How does it factor? Good. X minus 7 squared. Does this make good sense? Okay. Let's try a couple of others that may not make quite as much sense. Let's try, I'm still got enough room. Okay, let's try this one. X squared plus 5x. And I don't want you to use your calculator. And I don't want a mixed number for an answer. I only see about 5 of you that are still engaged with what I'm doing. Can you tell me what the process is, even if you don't know what to do? Can you tell me what you should be trying to do? Not half of 25. Half of 5. Isn't that the first thing we did? Look, when we got this one, you took half of 10. We did this one, you took half of 14. So we should take half of 5. But what is the appropriate way to say what half of 5 is when you're in algebra? Yeah, 5 divided by 2. 5 over 2. 5 halves. Half of 5. Stick it 200. This is what you're asking yourself. Half of 5. That's what you're asking. 5 is over 1, so it's 5 times 1 over 2 times 1. It's 5 over 2. Half of 5 is 5 halves. Do you agree?
Yes.
Now what's 5 halves squared? 25 fourths. Half of 5 is 5 halves. 5 halves squared is 25 fourths. Yeah? You follow that?
Yeah.
How does this factor?
X plus 2.5.
Not 2.5. 5 halves. Okay? How would you do this one? X squared plus, variety's sake, minus 11x plus.
$121 over 4.
He thinks it's 121 over 4. What a strange thing. Do you think he's right?
Yes.
What's the first question you should be asking yourself?
11.
Half of 11. And the way to answer it in an algebra class is 11 halves. What's 11 halves squared? 121 fourths. How does it factor?
X minus 11.
There you go. Now, I'm going to make it even worse, but try to follow the same scheme. Try to do the best you can. I'll give you time to think. Do not blurt it out until I call on you. See if you can complete the square on this one. If you want to use a paper and a pencil, you can, but you cannot use your calculator. It won't work anyway. Anybody, take a stab. Well, no, raise your hand when I call on you. Anybody think they know? I got one hand, 2, 3, 4. Go ahead, you were first. What do you think?
Looking for the number that goes after
Yep.
plus. Is that 3/4?
It is. Very good. What's the first thing you should be asking yourself? What's half of root 3? And what is that? It's root 3 over 2. Yeah. If 2 won't go into it, you just stick it over it. It's a fraction. Now when you square that, what's root 3 times root 3? 3. What's 2 times 2? 4. You see it? Now try this one. This is the last one, and then we'll go out and get on to something that this was supposed to be leading up to. Did I hear it? Did I hear somebody? What do you think?
12 fourths.
But what is 12 fourths? You thinking it's 3? It is 3. Because you could get 12 fourths like you just got. Or you could think of it like this too. You're asking yourself, what's half of 2 root 3, right? Isn't that what you're asking? And then we do it like this. Don't these cancel?
Yes.
Then when you square what remains, you get 3. Or you could do what you did and get 12/3, but you gotta reduce it. Okay, so that one completes with a 3. By all the things that we've been doing, folks, by figuring out what adds on to the end of this to make it a perfect square trinomial, the process of doing that by taking half and squaring it is called completing the square. Completing the trinomial so that it factors in a perfect square. So this one would factor how? X plus root 3 over 2. Remember, it's half that middle term, even if it's ugly. This one is?
X minus root 3.
Good. Because half of that cancels the 2 and it's root 3. So this is how it factors. But figuring out what goes back here so that the thing is a perfect square trinomial is called completing the square. And it turns out that having that skill is really important to coming up with an almost magical thing that happens when you go to solve a quadratic. It cannot be factored. And you're not going to graph it either. You're not going to use your calculator to get an approximation. You're actually going to get an exact answer in an algebra way. And that's what we're about to do. So I want you to consider this quadratic equation. 2x squared plus 5x minus 9. Now you got to kind of switch gears a little bit from what we were just doing. That was a skill that you're going to need to do this problem. But what we're really trying to do now is figure out what values of x we could plug in those two places so that the whole thing turned out to be 0. Normally, when we have something like this, we would try to factor it if we had to do it algebraically. If we were going to do it graphically, we would graph it and find the intercepts, but those would only be approximate. I want exact values today. So we would attempt to factor this. So here's how I would attempt to factor it. And I would say, I need factors of 9, so I could try 9 and 1 or 3 and 3. Those are my only options, either 9 times 1 or 3 times 3. That's all there is. So I'm going to try 9 times 1 and see if it works. This is how you check it. Remember, this sign is really important. So I would say 2 minus 9. That's 7 of some kind. I mean, negative or positive, depending on the signs. But that's 7. I'm looking for a 5. So it's not that. So I try 1 and 9, and that gets even worse because now I have 18 minus 1, which is 17. That's even further away. So it's not 1 and 9. So I try 3 and 3, and I won't have to reverse those because they're the same number. So see if this works. That's going to be 6 minus 3, and that's 3, not 5. What have I learned? This thing's not going to factor. So I got to come up with something else. Do you remember the other day when we had something like this? I said you can't solve this in an algebra way because if you try to solve for this x, you'll end up with x equals something with an x in it. If you try to solve for this x, you'll end up with x equals something with an x squared in it. You can't write x in terms of itself. And so it's not algebraically possible to isolate one of these. Or is it? And the answer is yes, it is, if you are clever and rather inventive. It has to do with the skill that I just taught you. So the first thing before we can use complete the square important is that this has to be a 1. Here's how I'm going to get rid of that 2. And it's a perfectly reasonable algebraic thing to do. I'm dividing every term by 2. What I'm really doing is dividing each side by 2, which is a reasonable thing to do. Why 2 over 2 is 1? That turns my leading coefficient into a 1. So now I have this. X squared minus 5 halves x, that's gross, minus 9 halves, still equals 0, because 0 over 2 is 0. So the first thing I did is turn this into a 1, because I can't complete the square on things that don't have a 1 there. If there's already just a 1 there, then you can skip this step. Well, actually, you're not going to be doing your problems this way. What we're doing here is what you would have been doing for every problem in section 3.3. You're not going to be doing that today. You'll see, and you'll be very glad and thanking me by the time we get to the bottom of this. Next thing, I want to complete the square on this and this. I don't want to look at that. I want to take those two guys right there and complete the square. So I'm going to get this out of the way next by moving it to the other side. Okay, now I'm going to play the game that we played just a few minutes ago, and you'll see why it's such an amazing thing to do. It eliminates this problem of having a squared term and a single term. You'll see it's pretty cool. Just a minute, it's coming up. How would I complete the square on this? I would have x squared minus 5 halves x plus what? What's the first question you should be asking when you complete the square? What's half of 5 halves? So if you don't know how to answer that question, write it out. You're looking for half of 5 halves, which is what? 5 fourths. Gosh, people, it's like pulling teeth with you. That's what you get. Now you have to square that. What's that squared? 25/16. Good. Equals, here's my 9 halves. It's still over there, 9 halves. But here's the problem. On this side equaled this side because I followed the algebra all the way through. It's balanced right to there. But now it's unbalanced because I've added something here. To get it balanced again, even though it'll still be heavier on both sides, to get it balanced again, I have to add that here as well. That's the rules of algebra. You got to keep that balanced right there. And I added 25 halves or 25/16 to complete the square. Now I made this side heavier. So I got to make this one heavier by the same amount to keep it balanced. Well, clear on the algebra so far? Okay, now I created a perfect square trinomial, and here comes the magic. It's going to be cool. Watch, I'll show you why it's magical in just a minute. What does this factor as? Just give it to us then. That is a factor. Come on, you can do this.
Factors out to be
X plus 25.
No, x,
plus 5/4.
not plus,
I mean,
minus. Remember, one of these, half of this. You found half of that in an attempt to square. So come back to here. Half of it was 5/4. Yeah, we following?
Yeah.
Now comes a little bit of a problem. Actually, I don't want to handle that problem yet. I want to show you the magic that happened that you didn't even see. Sleight of hand here. The problem with this right at the beginning was you can't isolate this x without being in terms of this one or this one without being in terms of this one because you've got a squared piece in one term and a single piece in another. And that's the same thing here. Got a squared and a single, squared and a single, squared and a single. And this magical factoring. We don't have a squared term and a single x term. We have a single x. And it's equivalent to this by that factoring. That's a cool thing. We'll be able to get at that x now. We got to figure out this side. But we'll be able to get at this thing now because what we have to do, what we'll do next is square root that square off so that this is exposed and then kick the 5/4 over the other side and we'll be done. But right here, from here to here, we turned it into an impossible thing into something that's really quite simple by factoring that perfect square trinomial. It's amazing. We got to simplify this side. That's a little bit of arithmetic that you have probably forgotten and you don't like it, but tough. What's the common denominator for these two? Because we got to have that before we can add them. 16. This one has a 16, so he's good. What's this one got to do? Happen? Times 8/8. Since we're really multiplying by 1, we're not changing the value, just what it looks like. So this is 72/16 plus 25/16. Well, 72 and 25. 97. We buy that?
Yep.
Everybody clear on that? It took a little common denominator business there to get that done, but this is what the right side simplifies to. It's the left side where the magic is. Because we can get at that thing now.
Wait, how did you get the right side?
This was 9 halves plus 25/16. I had to have a common denominator of 16 because that's the smallest thing that both 2 and 16 go into. This one already had the 16, so I don't need to do anything to him. This one needed to be multiplied by 8 to make his denominator 16, so I had to multiply the numerator by that too. 8 times 9 is 72, so I have 72/16 plus 25/16, and that's 97/16. Everybody clear? Now we'll get after that x. Now we can get to it. We're going to square root both sides, and when we do, we get x minus 5/4 here because square rooting that square takes it right off. Over here, because we are square rooting in the process of solving, you're going to have to put a plus or minus on it. Root 97. What's the square root of 16? 4. You can square root those individually. 97's prime. It's not going to square root, but the 16 will. You clear to there? Hang on.
This sucks.
What's bad is you're still recording. Okay, yep. I am not gonna have my face on this. Sorry.
This is extra credit?
Yeah, we don't have to do this on the test.
Oh, yeah, that's right.
It's a good thing to know, trust me, because you'll end up needing it later. Especially for you sophomores who are in here. Why is this not loading?
It's not, it has been recording the whole time.
It's been recording this whole time.
Okay, good. I'll tell you all.
It has. I just gotta change this thing. Because you'll end up using this a lot in pre-cal. And so it sucked because I didn't learn this lesson and I just ignored it after I was done with it. And I ended up having to relearn it all for freaking pre-calc. You're a sophomore, right? Yeah, you'll end up great. As I'm missing.
It has to be that short. It just took a while.
What is this, 93?
No, that's not right.
Oh, you're right. Oh, here. I will.
Computers.
Oh.
No, I'm not in yet.
You're great.
I'm just telling you. But I won't show up.
No, Kilbrook.
I'll see, I can't remember what the same one was. I'm being honest. Oh, was it yesterday? That was bad, right?
Someone happy to.
No. Can you remember that?
Is my.
I know.
There's a freaking chick out there.
Started reading was yesterday.
Rockets on safety.
Oh, yeah, it was started.
I'm sorry, chicken.
I always remember once you could start doing the study guide stuff.
Yeah.
I completely forgot.
Okay, so let's see where we are. Remember we square rooted this to get this so that we can get at that x? Because right now in the parentheses, x is trapped behind these parentheses. You can't get at it until you get rid of that. Well, we did. That was easy. We did it to this side too because that's what algebra is. And when we square rooted this, we couldn't square root that, but we could square root that. And it's plus or minus because we're square rooting in the process of solving, we have to consider both. There's only one step left. Well, actually two. One, the next step would be to toss this 5/4 over the other side so we isolate x. This is what we get. X equals. And it's customary to put this in front of this. We put the garbage at the end. The stuff that looks gross, it's irrational. So it's going to be positive 5/4 plus or minus the square root of 97/4. And the cool thing that happened here is we don't even need a common denominator. We already have it. So the final answer is 5 plus or minus the square root of 97 over 4. And there's actually two solutions here. 5 plus, by the way, square root of 97 is practically 10, right? Because 97 is practically 100. So let's pretend it's really close to 10. So the two things that where this parabola is going to hit the x-axis is at about 15 fourths, because 5 plus 10 over 4 is 15 fourths, or about 5 minus 10, which would be about negative 5 fourths, will be the other one. There's two hits, but this is the exact expression rather than something approximate from your calculator. And we know that the calculator answer is going to be approximate because the square root of 97 is irrational, which means its decimal goes on forever without ever repeating. So this is an exact answer and much more preferable in a lot of circumstances than the decimal equivalent. But the decimal equivalents will be somewhere around 15 fourths to negative 5 fourths. Now, this is the way you would have to do all of your problems if we were doing section 3.3. Every one would have to go from there to there. And you'd have to do 20 of them. That'd be horrible. And the reason why I believe that it's horrible and that you shouldn't have to be made to do that is because I'm about to show you a way where we can invent something that will work every time. Have you ever heard somebody say, you shouldn't have to invent the wheel every time you want to use it? Once it's invented, you should be able to use it as a tool, whatever it is. Well, we need to invent a tool for handling situations to get from here to here without that. While it's magical, it's difficult and lengthy and unnecessary with what I'm about to show you. This thing I'm about to show you is what you need to produce for 10 extra points on the next test. You need to know, if you're going to do this on the test, all it will say is derive the quadratic formula. That's all it's going to say. You have to know where to start and how to get through to the end appropriately. So the where you start is with a general form, quadratic, or standard form. So what we're going to do, folks, is we are going to do this right here to the general quadratic. It's not specific at all. And we're going to do it by looking back every time at what we did to this specific quadratic and try to do the same thing when we're dealing with A's, B's, and C's instead of 2's, 5's, and 9's. It's not going to be as bad as you think. What was the first thing we did over here? We divided by 2. What are we going to do here? Divide by A. Good. So that's the first step, so that we can make a 1 as the leading coefficient. And this is what we get. A over A is 1. So that's just x squared. B over A, I know it's bx over A, but we're going to write it like this so we can clearly see the coefficient. Stick the x out here. Is everybody comfortable with that? Plus C over A still equals 0, because 0 over anything is 0. What's the next thing we did? No, not yet. What's the next thing we did? From here to here. Toss C over A to the other side. Get him out of the way, right? Okay. We're going to have an x squared plus b over ax equals, when we toss this one over, it's going to be negative. Now we look to the left side to complete the square to make the magic happen. Okay, so when I complete the square on the left side, these two remain the same, but I got to add something onto them. Whatever I add on, I got to also add that on to this side to keep it balanced. Does that sound familiar? Sound okay? How do we determine what to add on there to complete the square?
I need the following students to come to the office: Nella Allen, Maya Carlson, Neil Crane,
What is
Jermaine
that?
Jackson, Caitlin Sears.
Half. That's what we want to do. Half of B over A. What do we get?
Logan Tower.
B over 2A. Very good. Now, what is that thingy squared? Just take a stab at it. If you're wrong, I'm not going to yell at you. I might. Probably will.
2b over 4a.
The 4A, well,
I know.
part of that is correct. It's not going to be 2B. It's going to be
Squared.
B squared over
4a.
4A
Squared.
squared. That's what I also have to add over here. So that it's balanced. That's probably the hardest step. Well, we'll see. Okay, what did we do next? We were at this step right here. We added that 25/16. How did we get from here to here?
We simplified it.
Not simplified, but starts with an F. We factored this. How does it factor? Since it's now a perfect square trinomial, how does it factor? Half of that was this, remember? Do you understand how that factored, folks? One of these, half of that. Well, half of that was the b over 2a before we squared it. Okay. Now we got to add this over here. This is a little tougher. What's the common denominator for those two things? Because they don't have a common denominator. No. What's the largest or the smallest thing they both go into? 4a squared. 4a squared. What's this one missing to make it 4a squared? A what? A 4 and an a. Okay, all right, okay. So if I multiply, now keep in mind that was negative because it was negative when we tossed it over. This is times right here. So what do I get in this one's numerator? Negative 4ac. This one already had that one, so it's just plus b squared. Are we following?
Yeah.
All over 4a squared, because that's the common denominator. Does that make sense? Or not?
It does.
I heard that from one person. It does. Want to know if the rest of you are on board? We good? Okay. What did we do next? It's not easy to see here because we did this mostly in our heads. But what do we do to get from here to here? Square root both sides. If I square root this side, what do I get? Good? Good. What do I get over here? Now be careful. Be very careful. First of all, you will get plus or minus. That's a given. Let me tell you a secret. You guys knew this, you just have forgotten it. When you go to square root this numerator, for example, you cannot square root this term by itself. This is not b. You can only square root things if they are factors. This is a term. Factors are things multiplied. This is being added. You cannot square root that b squared. Furthermore, it's prettier if we put the positive thing in the front. So I'm switching these two around, which is perfectly legal as long as they keep their signs. This thing, however, can be square rooted. Square root of 4 is 2. Square root of a squared is a. Just like over here, we square rooted the 16. It's square rooted, but the numerator didn't.
Well, can you do the 2a on the bottom again? That is.
The square root of 4 is 2.
Oh yeah.
The square root of a squared is a.
All right.
We good or not?
Yeah.
Okay, and then when we got to here, all we did was kick the 5/4 over and stick it in the front, right? That's what I'm going to do here. I'm going to take this term and put it over here and stick it in the front. This is what I get. X equals negative, because I'm coming over, negative b over 2a, plus or minus the square root of b squared minus 4ac over 2a. And lo and behold, the denominators are the same, which means that we can dump them all over 2a. So it's going to be negative b plus or minus the square root of b squared minus 4 AC, all over 2a, and you had better recognize that. You have worked with this before, or you wouldn't be in this class. This is the quadratic formula. This is the wheel, and we just invented it. Which means that we don't have to do this kind of crap for everything we run into, because we did that kind of crap in general. So I can go from here to there without this junk. That's why I didn't want to give you section 3.3. So, now we're going to use it. Try to tie everything all together now, wrap it up. By the way, by the time you are done with this section, 3.4, you better have this memorized. You will not get a cheat sheet or a card. Memorize it properly. Don't try to memorize it by just staring at it and having somebody drill you on it. Do it by writing this down every time and then doing the work on it, and every time you write it down, you'll get better at remembering. Here's the first one. And we're gonna use the quadratic formula on. We're gonna get straight from the equation to there without that stuff in between. Yes.
For the extra 10 points, you have to write down all of that or just that?
Oh, no, all of that. This you're gonna need to do the rest of the problem that is, or the rest of the test that is required. Okay, but you gotta do right. Yes.
So let's say we're on this extra kind of part of the test and we like get halfway through and we get caught up on, I don't know, like really towards
You
the
get
end.
nothing.
We don't get anything from
All
it.
or nothing. You gotta
All
get
or
it right.
nothing. Oh boy.
Okay. All right, so this is the first equation I want to solve using the quadratic formula. X squared plus 3x equals 5. Okay, in order to be able to use this formula right here, it has to be, the equation has to be equal to 0. And remember I told you it's a good idea to have everything on the side when the square term is positive? It is absolutely essential. When you use this, if your square term is negative, you're going to buy yourselves all kinds of trouble. You don't need to. So which side shall we put things on, left or right? So put them all together on one side in order, and then identify A, B, and C clearly. And A, in this case, is 1. This is A. B is positive 3. C is negative 5. Make sure the signs go with the numbers that are in front of you. So those are your A's, B's, and C's, and they're always going to be numbers. They'll always be numbers. Notice that the formula doesn't have any x's in it. The formula, the x is over here. This is what x is equal to, and these are all numbers, no x's. So you start by writing x equals, because that's what we're solving for. And it will be the opposite of b. When it says negative b there, it does not mean a negative number. It means whatever b is, its opposite. So in this case, negative 3, plus or minus the square root of. The thing that goes right here, right inside the radical, is always what you just wrote down here squared. So it will always be positive. Because you're squaring it. Whatever you wrote here, square it here. It'll be a positive number. Then make it a habit. Write down minus 4 parentheses. That way you don't have to worry about the negative 4 until the next step. If you try to worry about this and this AC product all at the same time, you're likely to make a sign error. Very likely. So just make it a habit. Minus 4 parentheses. Then come up here and say, okay, C is negative 5, A is 1, negative 5 times 1 is negative 5. Write that result here. You can do that arithmetic in your head. Over, now we have observed that A is 1, twice A is 2. Next thing, get inside the radical, follow order of operations, and clean it up. That will be negative 3 plus or minus the square root of. You have to do this product first. You have to multiply before you combine. So this is actually negative 4 times negative 5, which is positive 20. Then add the 9. You've got to get this product with the right sign on it first, and then combine it with the 9. This is 29. This is not 9 minus anything. It's 9 plus 20. At this stage, you look at what you've got in here and see if you can simplify it by prime factoring and taking out pairs. 29 is a prime number. Nothing's gone out of there. This is it. We got from here to here without all that garbage by applying this formula that we invented for all quadratics. Try another one. 25x squared minus 8x. 25x squared minus 8x equals 12x minus 4. First thing, if it's not equal to 0, decide which side you should put things on, left or right. Left. 25x squared leads because it's the squared term and there's only one. Negative 8x, we bring that 12x over, becomes? Thank you. Most people in second hour said 4. You're adding 12, you're subtracting 12 from something that's already negative. Negative 20x, and then? Plus 4 equals 0. So A is 25, B is negative 20, C is 4. There we go. X equals the opposite of B. Plus or minus, whatever you just wrote squared. Does anybody know what 20 squared is? 20 squared? 400. 400 minus 4 parentheses. Make it a habit. Then you multiply 4 times 25, and that is? 100. Over 2 times 25, what's that? 50. Now we get inside the radical and we do this multiplication first. It's a negative times a positive. That's negative 400. Added to 400 is 0. So we have 20 plus or minus the square root of 0 over 50. What is the square root of 0? 0. What happens when you add or subtract 0? Nothing. So this turns out to be 20 over 50, which is 2/5. What that tells me is that this parabola right here, if you graphed it, would bounce off just to the right of the origin at 2/5 at the vertex. Because it only has one solution. Let's try one more. I'm almost there. What?
Okay, it makes sense on this one, but on this one doesn't make sense for some reason. Why is it 29?
Because negative 4 times negative 5 is positive 20.
Okay, but why did you add 9 instead?
Because this is a combination. It's 9 combined with this result.
Oh, okay.
Okay, try this one out. Negative x squared plus 4x equals, is that 10 or 13? Yeah. Okay, not everything's on one side. Even if it was and the square term was positive, you take it all over the other side. What side should we put things on?
Right.
The right. And it's going to be in order, x squared and then?
Minus 4x.
Uh-huh. Yeah, because 13's already there. Good. So everything's on the right. A is 1, B is negative 4, C is 13. Here we go. X equals, what's the opposite of B? 4. Plus or minus, what's B squared? 16 minus 4 parentheses. What's A times C? 13. Over, what's twice A? 2. Good job. Okay. Get inside here. We got to do this first. What's negative 4 times positive 13? 4 suits of 13 cards makes
52.
52 cards, yeah, okay. So this is 52, negative 52. What's 16 combined with negative 52? Not quite.
Negative 36.
Negative 36? Yeah? Over 2. How do we simplify negative? The square root of negative 36.
That's an I.
That's what everything was about yesterday. So I get 4 plus or minus 6i over 2. Now, when every one of these things has something in common, you can divide 2 into 4, for example, that gives you 2. And you can divide 2 into 6 separately, and that'll go, that gives you 3. So that's what x equals in this case. It's imaginary, because this plus 13 right here moves the parabola up too high to ever hit the x-axis. Now, I have one more concept to teach you, and hopefully I have enough time. These 3 are perfect examples of what I want to show you next. There's only 2 concepts in this section. One's the quadratic formula and how to use it. The other one is a thing called the discriminant. This thing right here in the box that I'm boxing up in red in each case, that thingy, that number that's underneath the radical once you simplify it, that thing is called the discriminant. And if you were in a civics class or a government class, that's a bad word. We do not discriminate. Well, in math, we discriminate. We discriminate a lot, and it's a good thing. What this thing that I boxed up in red does for you, dang it, you should have been seeing all this. There you go. Sorry, dude. Let me grab this over here. Oh, have I got enough? I do. There we go. All right, there's all of those equations. Sorry, I've been talking about all those. Maybe this will help. Sorry, I forgot about you. Okay. The things I have boxed up in red are discriminants. If this is positive, then you can square root it and get a real number, right? Which means that this equation, because its discriminant is positive, has 2 real solutions, and they are negative 3 plus the square root of 29 over 2 and negative 3 minus the square root of 29 over 2. Those both show up on this real axis. They are real hits on the x-axis. This one, when it's 0, means there's only one real solution, because when that's 0, the plus or minus is irrelevant. You're adding and subtracting zeros does nothing. One real solution if the discriminant's value is 0. two imaginary or two non-real imaginary solutions if the discriminant is negative. Two imaginary solutions. Now, what is it that is the discriminant in general? It is this. So if you have a quadratic equation, and the question is, or what they're asking you to do is to determine what type and how many of the solutions are there. All you have to evaluate is this. Not with a radical on it, just that. So if I said how many and what type of solutions are there in this quadratic, all you would have to do is this: b squared minus times AC. The discriminant value is going to be 24 plus 49, which is what? So the discriminant value, it says find the discriminant, this is what you write. If it says what does it mean, you write two real solutions. Why? Because the discriminant was positive, like this one. And you'll be square rooting a positive number, which gives you two reals. How are we doing? You understand that? So when it asks you to find the discriminant, it is a number, and it's equal to this. From that, but depending on its sign, you will determine how many and what type of solutions. If this had turned out to be 0, you would say 1 real. If this had turned out to be -2, you would have said 2 imaginary. Do you all understand this? The discriminant determines how many and what type of solution you're going to get. I think I'm done. I made it. There are some story problems I'm supposed to do for you and share with you, but I'm going to leave that up to you to try. We'll take care of it Monday if it doesn't work out. We're only going to be here for 10 minutes tomorrow. If you've got any particular questions, I can help you, but I'm not going to have much time to clear things up. So take your questions on Monday. Do your best. If you can get all the way through it, then get it submitted on Big Ideas if you're eligible. Otherwise, get it done on paper. Show all your work. Here's the assignment for those of you doing it on paper. This is section 3-4. Are you ready? Numbers 1, 2, 3 to 27, odd. 28 to 36, 39 to 43, odd. 47 to 69, odd. Again, if you think that's a lot, you're right. It is a lot, but quadratic formula is one of the most important skills you need to be successful as you move on through math. So you got to practice it a lot. Okay? All right. Good luck with that. Sorry about the mix-up. Hope you got caught up. See you. Bye.